Okay, so before we start, it's important to say that we're going to cover a lot today. And in an ideal world, we'd spend quite a bit more time on this with you, but the presentation is being recorded, so you will be able to revisit it if you wish. And we've also included a number of links which you might find useful. I'm going to switch my camera off now because earlier on it was just interfering a little bit with the connectivity. Okay. So just to get started, please take a short time to have a look at these images and note in the chat how these images are the same but different. And the key word here is but. Good, I can see lots of comments coming in. Great. Thanks. So these images were taken from the website Same But Different Math. The word but is really important. So, instead of choosing ways that they're the same or ways that they're different, learners have to consider how the items can be both. So learners have to look at the features, the characteristics, and the defining qualities of what they're comparing. So this type of activity can help to support the development of mathematical thinking and problem-solving skills, as it encourages learners to look at things in a different way. It also shows that there can often be more than one solution, which challenges those assumptions that you're either right or wrong in maths. There's loads of different tasks on the website and suitable from early right through to 4th level. Really worth a look. So you can see the aims here, and I'm not going to read them out to you. But the main thing we want to highlight today is that problem solving should not be seen as something separate. It should be embedded across maths and, in fact, across the wider curriculum. The bottom part of the slide shows the different things that we're going to look at today. So just out of interest, we want to know if you've used any of these before. So there's a link to a poll in the chat, or you could scan the QR code on the slide. And I'm just going to give you a minute or so just to share with us which of these you have seen before. Okay. Thanks, lots of responses coming in there. So it's quite mixed. That's great, thanks for that. Okay, so there's no specific curriculum organisers or experiences and outcomes for problem solving, and because problem solving should be embedded across all areas of maths, and it shouldn't be seen as a separate entity. And as I mentioned earlier, it should really be embedded across the entire curriculum, but the focus of today is in ways we can do it in numeracy and mathematics. So this is an extract from the Numeracy and Mathematics Benchmarks document, and these are the skills that we need to support our learners to develop. Okay, I'm going to hand over to Yvonne, who's going to then take you through the next part of the presentation.
Thanks, Nanette. So now we will kind of have a think about, why is problem solving important? So we know that it's important, and mathematicians have always understood that problem solving is central to their discipline, because without a problem, then there is no mathematics. And I think as educators, we are becoming increasingly aware that providing problem solving experiences is critical if our learners are going to be able to use and apply their mathematics knowledge in meaningful ways. By providing rich problem-solving experiences in school, we're enabling our pupils to develop some of the key skills that are highlighted in the box on this slide. We are supporting them to develop their understanding and to be able to explain the process that they've used to arrive at the solutions, rather than remembering and applying a set of procedures. While many students may develop procedural fluency, they can often lack that deep conceptual understanding that's necessary to solve new problems or make connections between their mathematical ideas. It's through problem solving that students develop a deep understanding of mathematical concepts, become more engaged, and appreciate the relevance and usefulness of mathematics. The problem solving processes and the acquisition of problem solving strategies equip students for life beyond the school. If we think about the world that our learners are currently living in, it is an information and technology-based society where they need to be able to think critically about complex issues. Here is a list of the top 10 job skills of the future. And as you can see, problem-solving skills feature heavily on the projected list. We know that the learners that we have in front of us today will go on to do jobs that don't even exist at the moment. I think that this year has shown us exactly how quickly society and jobs can change. COVID manager certainly wasn't on my careers advisor list as an option when I was at school. But we know that some learners really struggle when presented with problem-solving experiences. For some, this can be through frustration because the solution isn't always clear right away, and the problems can appear complex, and they might require a level of perseverance, as the learners are required to apply different strategies before reaching their solution. Some learners become really engaged and motivated when presented with this kind of activity, but for some, not knowing the answer right away can lead to frustration, disengagement, and that fear of being wrong. So as teachers, we need to help our learners overcome some of these barriers, and we're going to explore this further over the next few slides. So in this video clip, Dan Finkelton explores the concept of being stuck, or the productive struggle as he calls it. So some things to consider as we watch this clip. Do we provide children with enough opportunities to be stuck? How are we promoting resilience and perseverance in mathematics? How can we help to shift that mindset away from being stuck so that it's not seen as a negative thing? And as teachers, do we model being stuck enough? So I will hopefully be able to play this to you now.
Hi, I'm Dan Finkel. And I'm a math educator. One of the things I get really interested in is what is the skill that's actually developing as students work more and more deeply in mathematics and go longer and longer in their careers. And I think there is one metric that explains almost the whole thing. And it is, how long are you willing to be stuck on a problem? And what I found is, young kids, maybe they can be stuck for 10 seconds or 20 seconds, maybe even a minute or two. And if they're really involved in like a playful experience, maybe even 5 or 10 minutes. Play kind of extends our ability to do this. As we get older, I don't know, maybe in grades 3 and 4, you might see 5 minutes, 10 minutes. And ideally, in the upper grades, you're going to see students increasing that to a half hour, an hour. By the time I was in graduate school, I feel like I was ready to spend a month stuck on a problem. And by the time you're a professional mathematician, maybe you need to spend many months or even years stuck on a problem. It is your willingness to be stuck in the productive struggle that defines how powerful you are as a mathematician. That is just one of the key components to the whole game. So here's the deal. We need to teach that, because if you're not teaching that, you are not helping your students to become better mathematicians. And what that means is you have to teach them to persist, to persevere, to struggle in a productive way, which means you have to give them the time to struggle. And this is the hardest thing as a teacher, because there are so many demands on your time, so many learning targets, so many things, and yet it is maybe the most critical thing to defend, to say there needs to be a time where my students can just dig into a problem that is worth doing and see if they can go longer today than they did the previous day. Get a little bit further before I step in to help them. Give them that time to extend themselves as problem solvers. I've seen students who go through school, and the longer they're in school, the less willing they are to spend time on a math problem. They're learning the opposite lesson that they need to learn, if that's the case. If you're less willing to spend time on math problems, if you see them as things you should just either know the answer to or you shouldn't even bother doing them, that is the opposite lesson we need to teach. We need to give students time to struggle and help them engage and extend themselves to become more persistent, more perseverant.
I don't know if when you were watching that, you maybe saw, some of your learners kind of resonating with you as he was talking there. But I think if we have learners who think that maths is all about being correct and, a right and a wrong answer, those learners are particularly going to need support and encouragement to take risks, particularly in some of the problem solving activities that we set. Tolerance of difficulty is essential in problem solving, because as Dan's video highlights, being stuck is an inevitable stage in resolving just about any problem, and getting unstuck needs time and lots of different approaches that not all of our learners have the kind of resilience to continue at. And so again, over the course of this session today, we will look at some of the different ways that hopefully you can continue to build on those skills with your learners. So we know that it's important that as learners and as teachers, the first thing that we do is take that time to establish a problem solving ethos, creating that space where mathematical problem solving can flourish. And we know that part of that, our teacher expectation of learners is essential. Learners are only going to be able to handle the complex problems by being exposed to them. And one of the ways that we can help learners become problem solvers is by repeatedly and explicitly giving them the opportunities to develop key problem solving skills. But the challenge for us as teachers can often be to get that balance between ensuring the problems that we set are able to provide the appropriate support and challenge, but also to give learners that level of success. So they need to be difficult enough that they're providing challenge, but not so difficult that the learners aren't going to be able to succeed at it. And we know that teachers who get that balance right are taking that step and being able to create resilient problem solvers who know that through perseverance, they're going to be able to succeed. Effective teachers also need to take the time to model good problem solving habits for their learners. So the questions are designed to help the children think of a variety of different strategies and materials to solve the problems. Providing learners with opportunities to communicate their ideas, explain their thinking as part of that problem solving process. And making sure that we have that increased wait time, pausing after questions, but also after children's responses come in. We're trying to establish that culture of curiosity and inquiry so that learners are engaged with learning more and more about maths. And we should also be looking at ways to kind of develop that independent thinker. And this doesn't mean that the children are learning alone away from us, but it's about looking at how do we develop activities which allow them to work independently from the teacher for some part of it. And I think if we come away with one thing today, Nanette and I hope that it's that you see that you need to help learners stop viewing problem solving as a series of steps or boxes and ticks to work through. That problem solving is that really messy process that both us as teachers and the learners are going to be more successful if we can accept that and learn how to work through that. Now, over our time in schools, we have seen a number of things that can sometimes be a problem when it comes to problem solving. And one of the things to be aware of is to think about some of maybe the classroom displays that you have. I know, for example, I had the maths garden up on my classroom wall, which is why the flowers on there. But actually, sometimes these displays, which we think are helping children, can actually sometimes help to cause even more problems. And if we take the example of difference here, the keyword difference often appears on the subtraction part of the display. But actually we know that find the difference could be a subtraction, but it could also be solved by counting on. And so we need to make sure that if we are displaying keywords, we're not limiting children's understanding with them. We also know that word problems can tend to be quite complicated because they have descriptive language in it. And sometimes learners don't actually understand exactly what they're being asked. specifically if the problem is quite abstract to maybe an experience that they've had themselves. And we know that sometimes issues arise when the learners lack the kind of fundamentals of maths. So they can't read the question, and then they don't have the language skills to know what maths is actually being asked of them in that question. And so this is a book that has been recommended about how to close the vocabulary back, helping us to kind of consider that level of word recognition and comprehension. We know that sometimes learners number grab. So they automatically see a problem, they see a few numbers and they just grab them and start working with them without actually taking the time to really read through what are they actually being asked to do. So we're going to give you some examples in the later slides about how to pose questions which prevent from that automatic number grabbing. Also, we know that strategies are used within schools. So this might be things like draw a picture, act it out. Some schools follow particular named steps and strategies, things like rucksack. But we need to make sure, first of all, that they are consistent. So there's no point in primary 4 having one set of strategies and in primary 7 something else. And also, are they consistent across your cluster? Because if we spent a long time preparing our children to go to high school, and actually we've got 5 different primary schools all teaching slightly different names for strategies, then that can become quite difficult for them as well when they are in mixed classes up at the high school. So we need to make sure that there is that consistency and that understanding across all staff that are working with children. But also we don't want them to become too gimmicky. It's really important that learners are given the time and the space to actually understand the different strategies that they can use. And it's more important that they understand the different processes and what they're being asked to do than necessarily being able to kind of tick the boxes on the sheet. And another thing is that sometimes learners can see problem solving as something completely separate to maths. So if you were to ask your children, when do you do problem solving? Would they say to you, oh, we do it on a Friday after break? Or do they see problem solving as something that's completely embedded into maths lessons? And also, do we provide enough opportunities for problem solving to be integrated across the curriculum? Because we don't want children to think that problem solving sits separately to maths. And we included this diagram because we really like the illustration here. And this comes from Mike Askew, the Professor of Mathematics in Johannesburg. And we think it really highlights that problem solving is interlinked to the other skills, with maths really sitting at the heart of it. And we hope that learners will see that problem solving is not something that sits separately to maths. And I'm now going to hand you over to Nanette, who will talk us through some of the different strategies that we can use to continue to develop that problem solving approach.
Thanks, Yvonne. So the first strategy we're going to have a look at is open-ended and open-rooted questions. And I know quite a number of you have said that you are familiar with open-ended questions, but we're just going to take a little bit of time to have a look. So it's important to note the difference between open-ended and open-rooted questions. Open-ended questions provide opportunities for different strategies to be used and for different possible solutions, whereas open-rooted questions can provide an opportunity for different strategies to be used, but there's still only one possible solution. So this is an extract from a mini pedagogy guide which we created, and the guide focuses on open-ended questions. These type of questions are great for differentiation as they allow for multiple entry points, and learners don't feel that they always get the easy or the hard questions. So it's a much more equitable approach. These type of questions can also provide great assessment opportunities as you can observe the approaches learners use and notice where their misconceptions lie. And if you follow the link on the slide to the Education Scotland guide, you'll find many more links to websites with examples and also some further reading in this area. So the next thing we're going to have a look at is numberless word problems. Not so many have come across these before, but so do you often find that quite a large number of your learners go straight to the numbers? Yvonne mentioned this earlier, known as number grabbing. I certainly experienced that when I was in school. Some pupils who would just highlight the numbers and then make a decision about something to do with them. So let's look at this first bubble. So what maths do you see? Some might say none, as there's no numbers. But if learners said this to me, I would ask them to have another look. You'll find that they then start to say things such as, there must be a larger number of girls, or whatever number of girls there is, the number of boys will be less. So then you can reveal the next part. Now we do have a number, but we still have to really stop, think and consider. Now we know that 135 girls entered the competition, so what else do we now know? So for example, someone might say there must be less than 135 boys. And finally, you would reveal the last part. And by this point, they've had time to really stop and consider the problem. And it also helps to pick apart what the language means through discussion. You'll also notice that there are not any questions being asked at this point. So learners could be asked to create their own possible questions. So for example, what was the total number that entered? Or how many more girls than boys entered the competition? So that's really just a shortened version of this. So I highly recommend that you read the story of Regina Payne, as the way she tells the story is really great. Is this something that should be used for every word problem? No, but it is a good way to prompt rich discussion, and it can provide a scaffold to support learners in attending to the information provided in their language. And it makes it much more difficult for it to become a number grab. So if you choose to use the numberless word problem approach, these are some of the questions which can be beneficial to use. You can encourage them to come up with possible questions about what they see throughout the process too. And this slide shows a couple more examples of what these might look like. You can find many more examples within the links provided. I won't go into these in detail, as you can go back and revisit the slides later on. Okay, so the next thing we're going to have a look at is slow review graphs. And this is something that only a really small number of you have said that you have seen before. So sometimes they're also known as numberless graphs or notice and wonder graphs. So essentially, these are graphs which are gradually introduced with a little bit more information added at each stage. So in this approach, it gives learners time to think, wonder, and discuss. As more and more of the graph is revealed, learners can refine their interpretation, often in quite surprising ways. So we're going to try it just now with this graph. So, what do you notice? What do you wonder? Please put your thoughts into the chat. So you might, for example, be thinking, you know, how many bars are there? I wonder why there are
four peaks, 4 spikes. What is it recording? Is this relevant? What does the bars represent?
Great, lots of great questions. So now I'd ask you to think about, we've added some more information. So has that changed your thinking at all? What do you think the bars now represent? So again, just take a few seconds to consider. Rainfall, no peak between May and October.
Is this the number of people? Is it school holidays? Is it COVID numbers? Is it illness spikes? Is it something that's seasonal maybe?
Okay, will we introduce the next bit of information? Okay, so we now have dollars. So spending on something, but I wonder what.
Somebody's asked, is it profit of a large company? Is it heating bills, Amazon sales, money spent on air travel?
Okay, I think time for the next bit of information. And obviously I'm going through this much faster than you would do with your class. So now we have that first peak is Valentine's Day.
People are wondering if it's a sale of seasonal cards or holiday spend, flowers, card purchases on Moonpig.
Well, I think we're getting close. Okay, I think it's time to review what the graph is. So, a nice little activity that really makes you think about what the graph is telling us. So there is a link at the top which takes you to the Slow Reveal Graphs website. I've got to, as a bit of a warning, it is an American website, so some of them are maybe not so appropriate. However, it's also something that you could probably quite easily put together yourself. Just using a graph on Excel and just gradually adding. If you do that, then please let us know, because we always like to be able to share good examples. And I think that there are some on there that are also sort of transferable across to us here in the UK. Okay, so moving on to the next. The next thing we're going to look at is more same less grids. So these are a really great way to make sure that learners are thinking while they practice, rather than just mechanically repeating the same thing. So I first heard about them at just from one of my colleagues, actually, within Education Scotland. And I think they're a great activity. So learners are always given a starting point, and this can be a number, a worded problem, or some sort of image. So starting with the given central object, pupils then have to try and make the minimum change possible to complete the other boxes. They have to change one aspect of the centre object, whilst also having to maintain a particular aspect. So this means learners have to attend to how changing one aspect of the centre object changes another, meaning they have to really think about how the change they are making affects the second property. So what changes, what stays the same? There's lots and lots of template grids available for all levels on the website of this page. And there are lots of different topics covered. So in this example, it's a second level example, but as I've already said, they can be used at any level, and the website has loads that are already made up that you can just lift and use. So here we've got the number 30. And if you look at the top of the grid, you can see that we're looking for the number of factors. So in the column on the left of 30, we're looking for numbers which have less factors than 30. And the column on the right, we're looking for numbers which have more factors than 30. And if we now look to the very left-hand side, we can see the word value. So in the row above 30, we're looking for numbers which are more than 30. And in the row below, we're looking for numbers which are less than 30. Confused? You might be a bit at the moment, but don't worry. We'll work through this example and it should become quite clear. So first of all, look at the top left-hand empty box. So in this box, the number of factors has to be less than the number of factors in 30. but the value of the number itself has to be more than 30. So the idea being that you make the minimum change possible to the original number. So if you can see here, the 30 has 8 factors. So this means that the number in the top left box has to have less than 8 factors, but have a higher value than 30. Oh, you're too quick. Into the chat with 31 straight away. Good. So you can see here that 31's in here because it's higher than 30, and it's also got less factors. So now let's have a look at the top right empty box. So this time we're looking for a number which is a higher value than 30, but it's also got to have more factors than it. So if we had more time, we could work through each part just in turn. Unfortunately, we really don't. So if we just click through the rest, then we can see how we can fill in the rest of the grid. You'll notice that just on the previous slide, there was some can't fill boxes, and you probably have already worked out that, you know, it's not possible, and so we would just put in can't fill in this box. And indeed the same applies, you know, there's 2 boxes like that. So here's just another example of another possible activity that would fit into the grid. And as I said, there's a whole host available on the website. And with that,
as well, Nanette, with some of the younger children, you might actually act this out, you know, kind of draw out a large grid, you know, have the bean bags and the hula hoops and kind of act it out with them as well. You know, you can kind of make it that more visual approach as well.
Yeah, that's a great idea. And with that, Yvonne, I'm actually just going to hand over to you.
Brilliant, yes. So yeah, we've got a couple more examples here. You can see kind of the one where the beanbag was early level, and we've got first level. And yeah, you can see that there are kind of endless possibilities of how this can be adapted depending on where your learners are in their part of the curriculum. So we are now going to have a little look at goal-free problems. So this is something that you might be familiar with potentially if you work further up school. I know that this is something that's used in quite a lot of secondary schools, and basically it's suggested in a paper that we will put a link to at the end, the Sweller paper, that sometimes in traditional problem solving tasks where there's that specific goal, it can be quite cognitively demanding because it's an unfamiliar context, there's lots to read, there's lots to take in, you're trying to work out what to do, and for some learners it's just too much all at once. And so this is where goal-free problems can be quite good as a sort of concept to have a look at. So I'll put up a little bit of information there as well. So basically with goal-free, it's when there's no specific answer as expected, the actual goal or the question part of it is removed. And it really encourages learners to kind of drill down and look at what information they can gather from what they're being presented with. So if I put this up here, we know sometimes traditionally, and this is what sort of Craig Barton's work found, that at times learners can become, I don't know, I suppose how you would call it, but they see one type of question and they automatically assume, so, oh, it's a graph, I've got to work out which is the most popular one, without actually bothering to kind of read any questions or read around it. And what Craig Barton found was that particularly when children then went to sit exams, they can have in their mind, you know, oh, it's a triangle question, it's always going to be trigonometry. And then when they begin to read round it, and they see that that's not what they're being asked, they then get really stuck because it's not the question that they're expecting. And so by providing pupils with that opportunity of goal-free problems, you're actually encouraging them to stop and look at the information that's being presented and, you know, what can you work out, what do you know, what can you learn from this before you're introducing a question to them. So by removing that goal, we're encouraging learners to consider, you know, what can you work out with no question being posed. I think it's important to remember that we wouldn't use this at the start of a block. Obviously, learners do need to have understanding. It allows them to demonstrate what they know. And it also encourages them to make links across different areas of numeracy and maths. So for example, this context appears within data analysis, but you can bring in lots of different examples where you are just presenting children with data and then they're having to suggest, what can they work out from it. So there's the link to the paper. You will get access to this. It all goes up on the SMC website a few days after the conference. And we also have a mini guide that's available on our Education Scotland professional learning community if you do want to read a little bit more about this. So you can see here's some different examples of goal-free problems that can be posed across different levels. And once you've given learners that chance to work out whatever they can, it might be at that point that you want to introduce a specific goal question. And then they should realise actually how much they know and how much they can answer. They've already done a lot of the groundwork, and then it's that final tweak to get the answer for the question that you've asked them there. So something else that you might have heard of is the same surface, different depth, or it's sometimes referred to as SSDD. This is also something else that's mentioned in Craig Barton's book. For those of you who were with us at the conference last year, Craig Barton was the keynote speaker. He's written a couple of books about how I wish I taught maths as his kind of top one secondary maths teacher, and kind of was written about how all the things that he wishes that he had known when he was a maths teacher. So with the SSDD, they are a kind of special type of problem based on observation. And we put an example up there. And we spoke earlier about that number grabbing. And the good thing about the SSDD problems is that actually, on first glance, the numbers often look very, very similar. It's that the question has been tweaked very, very slightly. So the learner is presented with a number of problems which at first glance do look very similar, but they each require a different strategy to solve it. So the learner needs to read the question very carefully in order to identify the correct strategy. The SSDD problems can be used in a variety of ways. At the end of a topic, they might be used as an alternative to providing a kind of large number of topic-based applications in context. They might be used as homework tasks, or they could be used as a means of revision and preparation for assessments. So the use of these problems encourages students to think hard about the problem that's being presented, and it allows them to benefit from the effects of revisiting at spaced intervals concepts covered previously. So, you might not have done addition and subtraction for a while, but having these built into your lessons means that even if, say, you're working on something like multiplication, they're still going back and revisiting, or money skills that you maybe haven't taught, for a few weeks. So again, as I said, we do have the Education Scotland mini guide if you want to see some more examples. The other great thing about a lot of Craig Barton's work is he often has a free website available. These can be often kind of more for upper school, and particularly into secondary school, but I have used this right the way down with primary ones, and I found that the website was just good for kind of sparking ideas and thinking about, right, okay, that money question's far too hard for primary 2, but actually I can see how I can adapt that to make it kind of more relevant for their context. So on the screen here, we've got more examples covering a huge range of levels. Once you've given learners a chance to work out what they can, it's at that point that you might then share the different strategies that they're using, talk about how did they work particularly ones out, which ones were trickier, why were they, and the site at the bottom is for those of you who are working in secondary, problems that are targeted more for National 5 maths, but again, just good to have links and a kind of starting idea for a lot of it. And then the last concept that we're going to have a little look at today is the use of Venn diagrams. This helps to encourage that deep mathematical thinking and to explore the mathematical relationship between one idea and another. And again, this is something else that features within Craig Barton's book. So at the very early stages, we would be hoping that you were doing this in that concrete way. So you might have things like hula hoops that are overlapping, and you're asking learners to sort and classify a given set of objects into 2 attributes. So here you can see that they're being asked by shape, so is it a rectangle, and also by colour, so are they purple? And then that interlocking bit in the middle, if they are obviously purple rectangles, they will go into there. So you can see that that's kind of how it starts off in its sort of basic stages. And then this is how it can begin to be used much further into children's mathematical understanding. So Venn diagrams are great for exploring properties of shape and number. The one on the screen here looks at fractions, and you're being asked, can you think of a fraction that could fit into all of the different regions? So if we look at region B here, you're looking for a fraction that the denominator is a prime number. But by the time you get into region G, you're also looking for the fraction that can't be expressed as a recurrent decimal and is not less than a half. So these challenges really make you think hard, but they are easy to start. You know, I think, again, for some children that can be really overwhelming, and I would certainly suggest maybe only introducing 2 interlocking circles at first, because often when being presented with 3 in so many different regions can be quite overwhelming for them. But what we would suggest is that you choose a region and you think of a fraction that would fit into that. Or you might even just start by thinking of a fraction and then thinking about, well, which region, for example, if you were thinking of, I don't know, say 5/8, where would that fit into? And then beginning to work on from there. And you know, again, there's a website up at the top here, that Maths Venn that Craig Barton has set up. They've got questions that are aimed right the way through from primary up to advanced higher. And once you've done a few from his site, they are the kind of thing that you can get quite into kind of making your own. And again, as Nanette said earlier, if you do go on to create your own, it would be great for you if you are able to let us know, because it's great to see examples that people have shared from these workshops. Now, we have spoken a lot today about our professional learning community. For those of you who have access to GLOW, and that should be anybody that's in a Scottish school, you will be able to find our professional learning community through there. And you will see that within our learning, teaching and assessment, we have got a section called Developing Mathematical Thinking. And when you click on there, you can get access to some of the important kind of documents and key government guidelines and things that sit under that. But the main thing that will hopefully be useful for a lot of teachers at the moment is there's lots and lots of different links, you know, ones that we've kind of highlighted as having really good quality examples of helping to develop children's mathematical thinking. So you'll see that some are from our partners, the likes of the SMC, you know, their challenges that they created, Maths Week Scotland, Edinburgh University, but there's also some kind of websites where there's lots of different examples on there. Maths for Love was the video at the beginning that Dan spoke about. That's where he's from. So again, if you've not had the opportunity to check it out, we would definitely encourage you to have a look at our PLC. That's where you'll find all the mini guides that we've spoken about today. So just to finish up there, here's some reflective questions that I'll put up on the screen. The word problem or problems is mentioned 69 times in the numeracy and maths benchmarks. And so although there's no specific curriculum organisers or experiences and outcomes, this is because the problem solving should be embedded across all areas of maths, and it shouldn't be seen as something that is separate. So if there's anything that you take away from today, we hope that it's that. Here we put a few questions to ponder over the next few days and weeks. And if you're able to pop into the chat one thing that you're going to try immediately, then please do. And I would encourage you to reflect on today's session. We would love to see any tweets, and make sure that you include the Ed Scott Maths account, but also the SMC account and the hashtag that's been mentioned today. And that is us for today. And when this slide does go up, you will see that there is all the links that we have mentioned are available on that final slide, so that you're not having to have scribbled those down there. But thank you very much for coming along today. We're grateful for the feedback, and we hope that you'll go away and digest some of what we've said today. And you've got until past until the next session starts today. So you've got time to have a quick screen break before you go there. And Nanette and I will be around if anybody does want to answer any questions, and you can either put this into the chat, or if you want to wait until there's fewer people here, you can ask us at the end. Nanette, I don't know if you've got anything else you want to add there.